Over 90% of Estonia's energy needs are covered by oil shale power plants. As a result, more than 6 million tons of oil shale ash residue is created every year. The ash is stored on a plot of land encompassing about 19 square kilometers. To date, 280 million tons of ash have been stored on Narva ash fields. Stratification of oil shale ash is an important environmental concern in Estonia. In order to find a solution to this issue, Estonian Energy, in cooperation with the Estonian Road Administration and Nordicon, have started a project called OSAMAT. The purpose of the project is to demonstrate the opportunities to use oil shale ash as a valuable construction material. During this innovative project, we tested the usability of oil shale ash for reinforcement of the subsoil. The chosen field of study was road construction. The first stages of the project were conducted in the Finnish laboratories of Rambol. Ash mixtures that would be suitable for subsoil reinforcement in road construction were tested there. When processing oil shale, different types of ash emerge, some of which are not suitable for construction work. The ash types with the most efficient reactions when mixed with subsoil were identified during the laboratory tests. In the next stage, 2 working methods were chosen for the integration of the ash mixtures into the road construction process. The methods were layer stabilization and mass stabilization. Layer stabilization is widely usable for areas with hard surfaces. In the standard procedure, the cement mixture is added to the layer underneath the asphalt concrete layer to guarantee road integrity and load capacity. The main component of the binding substance used is cement, the production of which is costly and can contaminate the natural environment. In the OSAMAT project, a large quantity of oil shale ash was used as the binding substance for layer stabilization. Mass stabilization is mostly used for areas with soft subsoil. Usually, the soft subsoil under the area of road construction is dug out and substituted with a more stable pit material, the digging and transport of which is time-consuming, energy-intensive, and burdensome for the environment. During mass stabilization, substances are added to the existing soft ground, which adds the needed load-bearing capacity to it. Stabilization is used in many countries, including Estonia's Nordic neighbors, the Finns. What makes the OSAMAT project unique is the binding substance added to the subsoil, oil shale ash. To test the 2 stabilization techniques, different test sections were chosen: the Narva-Mustajoe road section in Ida-Viru County and the Simuna-Vaetu highway in Lääne-Viru County. These road sections had all the required characteristics to test the oil shale ash technologies, such as suitable composition of the subsoil, a location sufficiently distant from human settlement, and the possibility for traffic detours. In the summer of 2011, within the context of the OSAMAT project, layer stabilization work on the Narva-Mustajoe road section was started. In the first stage of work, the test section was divided into 7 parts. In every part, binding substance mixtures were tested with different ash content. Work to remove the old road surface began. After the removal of the old road surface, a strong base course was built. The base course was covered with binding substances mixed with ash. The binding substance mixture was then laid by tractors which were specially adjusted for the purpose and allowed for the added quantities to be exactly controlled, so that the required amount of oil shale ash per square meter would be guaranteed. The stabilized layer was instantly compressed with a vibro roller. Timing was an important factor here. Compression had to be done within 1 hour of stabilization. By periodically measuring the compaction characteristics and required water content of the stabilizing material, it was possible to achieve the desired result with the highest possible quality. In the test section at Narva-Mustajoe, the layer stabilization work was finished in the autumn of 2012, and the highway was reopened for traffic. In the summer of 2013, the mass stabilization works of the OSAMAT project on the Simuna-Vaetu road section were started. In the first stage of the road work, the 500-meter-long test section was divided into 5 parts. In each part, different ash types and quantities were used in order to find the best possible composition for a binding substance. In the test sections, different quantities of cement were added to the ash. In the beginning of the work, the existing road surface was removed. After that, the subsoil was prepared for stabilization. The needed components for mass stabilization, oil shale ash and cement, were stored in 2 tanks. These substances, stored in containers, were passed through a mixer and into the subsoil. For the injection of binding substances into the subsoil, Finnish specialists were on hand to help, applying their years of experience and application expertise to the project. The binding substance was pressed into the subsoil at a depth of up to 4 meters by the mixer, thus ensuring even distribution of the mixture. Processed layers were flattened by a dig bucket and prepared for the next stage. A geotextile which separates different layers from one another was laid on the peat, which had been stabilized by the ash mixture. As a last stage, load layers were constructed with the purpose of compressing the stabilized subsoil. At the same time, they worked to separate excessive moisture from the stabilized layer and accelerate the strengthening of the treated subsoil. Throughout the project, tests were undertaken and measurements were made to compare the efficiency of different combinations of the mixtures. Processed road sections were covered with a temporary gravel layer and opened for traffic. During the 8-month period, the ash injected into the subsoil reacted with the peaty subsoil, while the road section obtained the required hardness. After 6 months, the temporary surface layer was removed, and the reconstructed road section was covered with a permanent, hard surface. The measurements were continued on both test sections even after the works were finished in order to observe any possible change in the quality of the roads. The results showed that the road surface which was stabilized with the oil shale ash was resistant and reliable. Since different stabilizing techniques and mixtures were tested during the OSAMAT project, it is only after examining the results from final measurements that we can be confident which methods are the most suitable for working with the Estonian subsoil. We believe that the Simuna-Vaieta and Narva-Mustajoe test sections confirm oil shale ash as a valuable construction material. The OSAMAT project helps to understand and exploit the byproducts of the oil shale industry. With the support of the project, we can take a step closer to an environmentally sustainable future.